Hey, it's Kyle, and we're going to be taking a look at part one of the homework one, where we are going to be using Clojure to create a function that can calculate the Jacobian of our helical curve. And then we can check this function that we create with the actual Jacobian function in JAX. So let's take a look at this and get started. So the first thing we're going to want to do is define our first function. We'll just call it get Jacobian, get Jag, and it's going to take in a function, which is going to end up being our curve function, but could be any function. Alright, and then we'll define our inner function, and we'll just define it as Jag. And that's going to take in x0 and h we just want to be essentially 0, so call it a very, very small number. And we want this x0 to be an array, so we want to say np dot at least 1d, make it so it's at least a one-dimensional array. X0, and we'll create another array, f0, and we'll say the same thing, np dot at least 1d, an array of the function values at these x's. Now we want to create our array for the Jacobian, so we'll create another array j, and we'll just fill it with zeros for now because we'll be going in and changing those values in the next step. So np.zeros, and we want it to be the size of the two arrays we just created, so f0.size and x0.size. Go. And now we want to run through that array that we just made, and we'll be changing the values in it as I mentioned. So for I in range of the size of it, x0.size. Now we want to create an array of a new set of x values, but it's our x plus h values. So we'll just call that x, and we'll copy our x values, so copy x0, and then we'll go through each term in this array we made, and we'll make it our original x's plus h. And now we want to do our Jacobian values, and we'll use the actual formula for a derivative to make these. So as we know, it's the function of x plus h values, so that array we just made, x, and then minus our original values, so f x0. Actually, sorry, we don't need to do that. We made that up top. It's just f0. And then divide by h, and then tell it what term in our array to actually modify. So we want to do the second one. And now on this inner function we have, we're going to want to return our Jacobian array that we made, so we'll return j. No, just j. And then on the outer function, our getJack function, we're going to return our inner function. So it should be good. Yep, here we go. So now I'll create a function jack1 And we want to feed it, we want to feed these Jacobian functions our curve function that we made for a helical curve. And all we want to change is different t's. We want to keep r and mz the same, so we can use a lambda function. So we'll say get jack lambda t. I spelled that wrong. Curve, and like I said, change our t's but keep r as our global r that we named. Sorry, r equals r, and mz, the global mz. And now we can take a look at it. So we'll do Jacobian at 0. And there we go, it gives us our value. And so the way I talked about we can check this, we can just use a function in jacks. So we'll call jack2 just to take a look. Jack2 will set equal to jacks dot Jacobian, which will take the Jacobian for us. And then we want to do the same function, so we can just do the same thing down here. And now if we call on it at the same point, just to check to see we get the same results, we can do jack2 at 0, and we should get 0, 3, and 0.4. So let's take a look. 0, 3, and 0.4. So looks good. Alright, and that wraps up part 1 of homework 1. Thank you very much.